Just kidding. I wasn't actually speaking. Alright, so up until now we focused on motion and communicating and representing motions. We've also barely touched on the idea of changing motions. So we're going to discuss what it is that causes motion to change. So here's our essential question. How do we model the cause of motion changing using forces? We need to be able to define types of forces, be able to identify the agent that exerts a force on an object, and be able to draw the forces acting on an object. We have to be able to articulate and apply Newton's first law, and that's it. Here's our textbook alignment with college physics. If you're looking for the university physics version, it's going to be different. Here we go. Lots of words this time. We have force. We know force as a push or a pull that an agent exerts on an object. So this is a little bit more in-depth of a definition than you're used to. We use symbol F, and the units that force is measured in are called newtons. Probably named after Isaac Newton. You know. An agent is the physical, tangible thing that exerts the force on an object. An object is the physical, tangible thing that has a force acting on it. And a mass is the amount of matter there is in an object, measured in kilograms. And the symbol for mass, we use lowercase m. Inertia is how difficult it is to speed up or slow down an object. An object's inertia is the same as an object's mass for the most part. Well, this isn't technically true. It's true enough for us. Another way to think of inertia is the resistance to change, its state of motion. So an object at rest is going to be more difficult to get moving. A heavy object at rest is more difficult to get moving than a lighter object at rest. Now we have weight, which is the force that gravity exerts on an object. Again, symbol in Newton's. Normal force is the force that a surface exerts on an object that is directed perpendicular to the surface. Friction is the force that a surface exerts on an object directed parallel to the surface in order to prevent an object from sliding. We use F sub F for frictional force. For normal force, we're using F sub N. Both of these, because they're forces, they're measured in newtons. All forces are all relatively interchangeable. Tension force, the force that a rope, string, cable, or cord exerts on an object. And it's always going to be parallel to the cord. Symbol F sub T for force tension. Newtons, again, elastic force, the force that a spring, rubber band, or other elastic object exerts. F sub S there, again, we're measuring in newtons. We have an applied force. Applied force, it's not great. We can usually get a definition of what the force is, but it certainly simplifies things to think of an applied force. That's the force that a human hand exerts, F sub A. Newtons and gravitational field, a region of space where objects experience gravitational force. Symbol lowercase g, newtons per kilogram. Drag force is the force that air exerts on anything moving through air. Air resistance is what you know it as. It's always going to be opposite of the object's motion. So F sub D is our drag force, or F sub air is force air. We're using Newton still. We have a contact force, any force that requires something to touch the object for the force to be applied. Non-contact force, or field force, any force that does not require something to touch the object for the force to be applied. The net force is the vector sum of all the forces acting on an object. Symbol F net, force net, or sigma F. Sigma, remember from math class, means sum of, so the sum of your forces, measured in newtons. And that's our vocabulary. Hey.